the 18-minute mark, I'm going to pop in and give you the 2-minute warning. And all the audience evaluations. So everybody who's on Team Collect 'Em All, please make sure you get your evaluations submitted before midnight tonight. And though you'll do that through the link that Dr. Dabru has just put up there in the chat box. All right, team, do you guys have any questions for Dr. Dabru or for me?
No, ma'am.
How hot is it outside?
How hot is it? I haven't been outside. I'm too busy to go outside. And
Yeah.
been sitting here in McCain Hall all day. All right. Okay, guys, whenever y'all ready, y'all can start.
Hey guys, I'm Alicia Gabo. I'm a computer engineering major. I'm the team's lead, assisting on the software part of OvenMax, designing our website, and designing our smartphone application.
Hey, I'm Yasin Simpson. I'm a computer engineering major, and I'm the software development lead for this project, focusing particularly on the Raspberry Pi and the app.
Hello, my name is Anthony Lee. I'm majoring in electrical engineering, and I'm working on the hardware mount, and I help out with the power.
Hey, I'm Tyler Woodbury, computer engineering, helping out with the software and hardware, but mainly particularly the timer code.
Hello, I'm Rashad Williams. I'm majoring in electrical engineering. I help out with the powering and the wiring of the project. Our
faculty advisor is Dr. Ali Gerbouz. He's an assistant professor here in the ECE department at State. He got his PhD in ECE at the Georgia Institute of Technology in 2008. He's the co-director of the Empress Lab here on campus. His interests includes machine learning, computational imaging, and compressive sensing. The outline of our presentation begins with problem and solution.
Let's start by discussing the problem that the UMS addresses. According to the NFPA, unattended cooking was the leading causes of cooking fire. 1/3 of the people killed by cooking fire was because either they were sleeping or forgot that the oven was on. The number of people living with Alzheimer's increased and projected to around 14 million cases by 2050. Upgrading common oven to smart oven would be very expensive when smart ovens are $1,000 plus per oven. To solve these issues, OvenMax intends to offer some of the same functionality as smart oven while being cost effective. Because many people buy smart oven for the safety features, OvenMax was designed to confirm the following design constraints. OvenMax has the ability to connect to Wi-Fi, and also we designed our device to have a user account so that the user will be able to pair with his or her devices through their smartphone or laptop. The OvenMax power cannot exceed over 16 ampere at 120 volts. We designed a mechanical arm that turns off the oven while the user is away. We also provide environmental casing that will protect our device from stovetop hazards like hot water, steam, and other things that could affect the performance of our device. OvenMax provides a push notification to the user phone or laptop to remind the user of the time and any warning that the user should be aware of. OvenMax has its own oven timer control, which helps to prevent house fires, and OvenMax will cost around $200, which is a very cost-efficient add-on compared to buying a smart oven. Our product is very reliable because our device will shut down and work properly even when it's disconnected from the Wi-Fi. In addition to our constraints, OvenMax follows these engineering standards. We use IEEE 802.11 as one of our standard documents to specify Wi-Fi communication and notification. Our second document that we use is NFPA 72 to get the table for our power constraints for the kitchen. The last document that we use is the IEC 6052 to integrate protection against dust and water particles.
This image shows the overall layout of our design. As you can see, the Raspberry Pi is basically the heart of it. It helps with the transmission from the device to the cellular application. Also, it works in tandem with the motor driver. It will basically set the speed and provide additional power to the DC motor. This image also shows how the power supply is connected and how it powers both the DC motor and the Raspberry Pi. This is another image, and it's of the prototype thus far. At the time of this image, we were working on the DC motor and trying to get it to rotate. That's why you can't really see the mechanism. The design team wanted to get the motor running correctly before attaching it to the mount. You can see the motor driver and how everything is hooked up to it. You can also see the power supply we are using to power the Pi, the motor driver, and the DC motor. The most important characteristic for the mount and the attachment was that it needed to be able to access different types of ovens and their corresponding knobs. This was why it was important for the design team to test these capabilities with a group of different ovens. I tried up to 3, and the results were a little mixed. On one of the ovens, the DC motor attachment that connects to the oven's knob was able to rotate easily, but the mount that holds the motor up to the knob didn't quite fit the oven. On oven 2, everything worked out perfectly. As for oven 3, it was the opposite of oven 1. The mount fit, but the C-clamp was not able to rotate. I was testing with the knobs that control the stovetop, and they were very close together. When I tried to rotate the C-clamp, it would hit one of the other knobs and prevent it from rotating. It's very hard to try and solve these issues because there are so many different varieties of ovens. What may work on one may not work on another. Ultimately, this will help improving the previous mentioned state that the mechanism will help in the rotation of the oven's knob, and the next 2 weeks will be devoted to improving its efficiency. As for further testing, I want to proceed with going to a larger case. Maybe test more ovens and see the overall percentage on how each part is fitting with each oven. If there are further failures, maybe another option may have to be considered or a slight modification on either the attachment or the mount. And this image shows the C-clamp. It will be rotated by this DC motor. This is what I've been testing with. It could be improved upon, and that's another thing that I'll work on before we have to present the final prototype. Right now, or currently, it's a little bit too big, and it's hard to get it centered when attaching it to the oven's knob. Really, finding a way to center that C-clamp will be a challenge, but I'm currently looking into options. And the motor control consists of 2 properties that need to be tested. The physical attachment that will help the DC motor in rotating the oven's knob, and the code that will control the positions that the motor will turn to. As for the physical attachment, the only things tested have been through physical force. I basically attached the 3D printed object to the 2 metal rods, like on that C-clamp, and physically have to rotate it. So far, it has been successful with these types of tests, and the team hasn't yet had the opportunity to hook the DC motor directly up to the physical attachment.
The motor control factors into is a significant part of the Raspberry Pi's primary function. We needed it set up so that timer triggers caused elsewhere, caused by the user settings, whether they set it from their smartphone application or from the Raspberry Pi. They needed that they need that to be able to set the timer, and then we needed motor control implemented such that we could have the oven max shut down the oven at the end of that timer. All the wiring that goes into, much of the wiring that you see in this picture went into just getting digital pin level control of the motor. We had to wire it through a motor controller, power the Raspberry Pi, and then we had to get equal logical ground. But all of that wiring was just to control the motor. Now, the test that we ran, and that is depicted in this image, was to we operated our DC motor successfully. We got it running for 5 seconds clockwise and then 5 seconds counterclockwise successfully. We turned the motor like we had intended. Unfortunately, the test showed us that we used the wrong kind of motor. This is a DC motor, which is meant for continuous motion, whereas we needed a stepper motor, which is more precise angularly and could give us an accurate general position of the motor. The second, but this was overall a milestone for us. It was us assembling all of our hardware subsystems to get the physical side of our device to work, and this would, at base, could be interfaced with an oven for testing. But nothing else other than that. That was.
The power supply is to connect an outlet using a 110 volt standard power cord. The power supply is in turn power both the motor, DC motor, and has the ability to power the Raspberry Pi. The power supply being used has special capability. It has the ability to have a total of 3 outputs, which is 5 volts, 12 volts, and -5. On the left side of the power supply is labeled L and N, which means line and neutral. This is where the AC power cord will be spliced and put inside and screwed down for terminals to connect. As perfectly labeled, it's not perfectly labeled on the power supply, so I will do a little bit of explanation. If we were to closely examine the power supply on the screen, positive 5 outputs 5 volts, positive V2 outputs 12 volts, and V3 outputs -5. The section that is labeled COM on the screen will be common ground for the negative inputs from the Raspberry Pi and the DC motor. As you look at the screen, this is the testing that we have done with the team to test to see if the power supply was working and to see if we were able to pull the necessary power for the design team for both the Raspberry Pi and the motor controller. The first thing we did, we built a circuit. We need to power both the DC motor at 12 volts and the Raspberry Pi at 5 volts. We separated the circuitry on a breadboard, splitting up into 2 different fields, which is 2 different power rails. On the left side of the picture shows the circuitry that is powering the Raspberry Pi. We were able to successfully pull 5 volts required to power this device, and on the right side shows the circuitry that will power the DC motor, which required 12 volts. The next step was to plug the power into the associated devices. The team was successful in powering the DC motor and get the motor controller to respond to the associated devices. The team was successful in powering the DC motor and the corresponding motor controller. On the other hand, fearing to mess up the Raspberry Pi, we are headed to test it right now. So this part of the test is in progress. By the final prototype, we hope to be powering both the DC motor and the Raspberry Pi at the same time, so we wouldn't have to mess up the Raspberry Pi.
Until this point, both in testing and in docs, we had been focusing mostly on the Raspberry Pi side of our design, the actual physical interface that turns your oven off. Overall, though, what we had in mind, we had intentioned a 3-layer structure for our design that allows users to remotely turn off their oven Macs. The user would interface with, they'd use their smartphone application that we provide, and they go through a user account so that they could directly access their oven Macs timer settings and notification settings. In order to have a user account, something that naturally flowed was we need a database to actually store on a software level the credentials and the actual settings and any kind of data that needed to be transferred for updating on either side. For example, you want to set a timer, you've got to log in from the smartphone application. Then you change whatever settings you'd like. Those settings get updated to a database, and the Raspberry Pi is constantly checking for updates, just to give a general overview. And then after we had those 2 core features of our app integration, we found it reasonable to provide a shutdown guarantee And that's us promising that in the use cases provided in the if you use OvenMax as intended, then we will not burn your house down. Your house is safe with us. The more in depth on the user account, as I was saying earlier, it's a necessity for this kind of project structure that we have. We want users to be able to interface with their OvenMax specifically and securely. So that just basic level authentication and security, they have to have a user account. That flows pretty naturally into us requiring a database. As far as where we are with testing on the database, there was a couple, not complications necessarily, but complexities. It was complicated in that Flutter is a framework, and frameworks have access to a lot of software libraries to get things done. And each of those software libraries that are available to get the same thing done will have their own pros and cons within each one of them. So testing for this subset involves weighing those pros and cons against each other, considering how easy it is to implement one setup over another, or how memory intensive one is, and things like scalability, just if so that database load, for example, didn't get too high for the structure that we had. But nope, that's all.
We implemented shutdown guarantee as an extra safety measure to guarantee the oven shutdown. Okay, so picture the user goes out to the grocery store, and we additionally send a push notification and let them know that the timer is expired, and if they don't turn it off, we will. As Yasin was saying, I was able to get a database created, but for some reason it wouldn't update. Like, as I was running through Flutter, Flutter has a lot of different database packages in it that weren't all connecting. It would create the database, but it wouldn't update. So that's the issue we're working with now. Once we get that set up, we will be testing the shutdown guarantee by disconnecting and reconnecting the Wi-Fi. Here's the team's progress so far. Most of our deliverables from early on are done. We're still testing some of our designs, so our evaluation document is not yet complete. Our final design document is also in progress, along with our prototype. Conclusion, we ran into a lot of obstacles during testing. We found different alternatives into tackling these obstacles. One thing we also have to work on is finishing the casing for our prototype to protect it from any harm or making it not work. In the future, we plan to work with different oven models, and I will let my teammates talk about any other obstacles that they want to discuss during this time.
Since we haven't got the 2-minute mark yet, I'm gonna go ahead and talk about the difficulties that we ran into on the power side. Very short and brief. On the power side, the power supply that we had used initially only had a output of 5 volts and was only going to give 4 amps overall. The Raspberry Pi and the DC motor both require over 3, if I'm not mistaken. So that was not going to work. And also the DC motor required 12 volts. It was impossible for that particular power supply to power both. So we ran into a big issue with that. So the power supply that we have now is already explained, but I'm going to a little bit more detail. As you guys look, it has a channel 1, 2, and 3 with the first one named +5. That particular one is going to power the Raspberry Pi. And so on the DC motor, which is V2, it powers +12. And so if you look back at the presentation, it said 12.08. So it gives us a little room, so it's pretty nice of a power supply where it has a double output. So both positive terminal will go into their respective places, and then the negative will go into the common ground. So this power supply, this is one of the major things that we ran into, because the power supply, we had to redo the circuit, everything that we had to do. Me and Anthony came up very good on the power supply and getting everything to power good. So right now the presentation and the way the project is going, the power side is going very smoothly.
All right. You guys are right at 19 and a half minutes, so we better wrap it up.
So we're just gonna open the floor up to anyone who has questions, professors and students and colleagues.
So the first question for Anthony. So did you run the mechanical arm with the motor or not?
Give me 1 minute. Okay. Oh, no, ma'am, not yet. I mean, the attachment's ready, and in a few days we will. In the upcoming days we will. It's
So you tested the mechanical arm with the hand?
just with physical force, yes, ma'am.
Okay,
just
with the
rotating
force,
with
okay.
my hand.
Okay. So are you going to, because you need to know how far it has to rotate the motor, right? So did you order the stepper motor now, or what is the progress on that, Yasin?
That's as soon as we found out about that, I ordered that part in. I ordered a stepper motor that we would need to properly do this product. It came in today. I haven't gone to go get it. That's actually the next thing that I was going to do after this. But we have a stepper motor in, so that's not an actual interruption.
So, and you know how far it has to rotate back to off position, right? Do you know
I do not, but having a stepper
how
motor.
do you define that? Yeah.
I've read a bunch of the documentation
Mhm.
on stepper motors, and in particular the stepper motor that I got. Positional control is the intention of a stepper motor. They're created for positional control, and as a result, it'll easily map to whatever we need to turn, as long as we stay consistent with one size of knob, so that angles remain the same, and so that angles remain the same. That's what I said.
So the smartphone application is not working
Because
of the database issues.
Yes. Somebody is vacuuming right now. I'm sorry about that. It's working. Like the database would create, but for some reason it wouldn't update. So the login screen would take in like the fake email and password that I would use, and it was creating the database, but for some reason it's not updating. So that's our issue now. We were using it through Firebase. I was testing that one on Firebase. That's like a package that Google has for real-time databases. It was just creating, wouldn't update. We're looking at other alternatives because Flutter has a couple different database packages. That was just one that was recommended first, and I'm not really liking it, so I'm going to try another route with that.
And Flutter is not working?
No, Flutter
is working.
Firebase is the issue.
Okay,
Firebase
no. In the yeah, okay. In the presentation,
Flutter is
you
working in
mentioned
the
something.
emulator. Yeah, it's just the database. It's not Flutter.
Okay, the Flutter is working. Only the database is not working. Okay. So Rashad, the power supply, you bought it, right? It has two outputs, 5 volts and 12 volts. Is that correct?
It actually has 3, to be honest, because the I have to remember how it actually looked. On when it labels positive 5, it outputs 5 volts. V2 outputs 12 volts, and on the left it says V3, which outputs -5. We don't use the -5, so it outputs.
So my question is, so we are not making that. I mean, we bought the power supply, right?
Yes.
We purchased the power supply. Okay.
That power supply was stored.
Okay, it was store bought. Okay, good. Yeah, I mean, I felt like you guys haven't prepared. I mean, okay, don't get tensed up. Okay, I know you are. I mean, you need to work more. So don't get tensed up. Okay, I can see the tension on your face. Okay, you all are nervous a little bit, but it will be fine. Okay, so you have next week. to work on that. So I will come next week sometime to check on your projects. Okay, just let me know when you are done. Okay, so we can have enough time to. So yeah, now I will open questions. Okay, if Miss Nordin has any questions and the audience.
Well, actually, we might have time for one quick question from the audience. I think you touched on a lot of the same things. It looks like there's just the several things that are in progress that you guys got to work on wrapping up. All right, guys. Well, we are about to hop into Collect-em-all's presentation now. So y'all will be the reviewers for Collect-em-all. So we're going to close this meeting and hop over there. Okay.
Okay.
Yeah, talk to me when you have any, questions. Okay.
Okay.
Bye bye.